At the end of the last video, we talked about the strength of the carbon-carbon triple bond relative to that of a double or single bond. And we said that, because we're increasing the S character, it makes it a stronger bond. Now, I'm going to tell you something that may seem a little counterintuitive at first, but once we understand what's going on, it should make complete sense. And what I'm going to tell you is that the delta H of formation for alkynes is much less stable than their constituent elements relative to that of alkanes and alkenes. So we find that alkynes tend to be less stable than alkenes, which tend to be less stable than alkanes. Now I just told you that the bond is stronger, so how can it be less stable? Well, remember when we talk about bond strength, we're talking about a complete dissociation of the two carbons. But that doesn't mean that they are less reactive toward their elements. And the reason for this plays out in thinking about the particular structure of them. So, for example, if I look at the delta H of formation of butane, I see it's a negative value, and therefore it's an exothermic reaction. And to form butane, energy is released. However, if I look at an isomer of butene, namely trans 2-butene, I see that, well, the formation is slightly exothermic, but not as exothermic as butane. And when I go to butyne, 2-butyne, I see that the delta H formation is actually endothermic. Now, what's happening? What's the difference between an alkyne, an alkene, and an alkane? Well, the more pi bonds in a molecule, the more positive the delta H of formation is. And that means that at the surface, an alkyne is actually less stable. It becomes more reactive. So the more pi bonds a molecule has, the more reactive it becomes. Even though the bond length is shorter and stronger, the pi bonds actually reside further from the nucleus. And therefore, they are more reactive, more conducive to donate themselves to other things, which we're going to see a little bit later on. So the more positive the delta H of formation, the less stable it is. May sound counterintuitive. We have a strong carbon-carbon bond, but because of the nature of the pi electrons, those pi electrons actually make it less stable, more reactive toward other substituents.